Welcome to Static Talks. I'm your host, Dave Long, founder and president of StaticWorks. We make static control flooring. In our podcast, we'll discuss the threat static electricity poses to your business and how to address those risks. Rick, do you remember that question this morning about the PU coating on the ESD vinyl tile?
Yes.
And the testing?
I do.
Back in 2014, the ESD Association revised a standard called ANSI ESD S 2020. And one of the parts of that standard call out for requirements in ESD flooring. And those requirements have to do with several different parameters. So when we look at flooring, there are several properties we're actually hoping we can identify so we can determine if we're going to be able to achieve what we need to with our ESD program. So one of the properties we look at is electrical resistance, and we measure that using an ohm meter. Historically, when flooring has been qualified and certified after installation, the method of doing that was to take an ohm meter and take two of what we call NFPA probes, which are basically a couple of 5-pound weights with a rubber elastomeric material that's conductive on the bottom of them. Mm-hmm. And we set these probes down on the surface of the flooring, and we measure the resistive properties between two probes. And then we take one of the probes, disconnect it from the ohm meter, and instead make that connection to a ground source and measure the resistive properties from the probe that's still connected to the ohm meter through the flooring to the adhesive to ground. And we call that test a resistance to ground test. And before 2014, if the floor measured less than 10 to the ninth, which is a billion ohms, so if the floor measured less than 10 to the ninth, and then we did a second resistive properties test, which amounted to standing on the floor in place of the probe. So picture this. Instead of having a probe on the floor, you're standing with your ESD heel straps or your ESD shoes, and you become the probe. So you take the test lead from the ohm meter, you hold it between your fingers, the other lead is attached to ground, and we make a measurement that includes your body, your ESD footwear, the floor, the adhesive, all the different items that are used to make that connection to ground. So that test is called the system resistance test, and that test standard is it ends in 97.1. So it's ANSI ESD STM 97.1. So before 2014, you would do these two tests. You would test the floor with the 5-pound weights, and you would test the floor with a person essentially acting as a probe. And if the 5-pound weight test measured under 10 to the ninth, and if the system resistance, which included the person and their heel straps, measured less than 3.5 times 10 to the seventh, you would say that that floor now qualifies for use in an ANSI S2020 compliance program. And that was the end of it.
But it sounds like that type of test does not actually produce a useful measurement, right?
The major downside to relying on that test is that you're using resistive properties as a predictor on whether or not when a person walks on the floor, they'll generate a static charge. Now, we measure static charges in volts, not ohms. So right away, we're using a test that measures a different property, using different unit of measurement, to predict a property that kind of has nothing to do with resistance. And I guess the way we want to describe this as it played out, we would often see conductive floors which measure less than 1 megohm in any location on the floor, whether it was an epoxy floor or I don't know, whatever type of floor the client might have. But under certain circumstances, even though the floor measured in the conductive range, when a person would walk on the floor with their ESD footwear, they would generate, in some cases, hundreds or even over 1,000 volts of static electricity. And of course, that doesn't make sense to some people because they're thinking, if the floor is conductive and you're wearing ESD footwear, how's that possible? Well, remember one thing. Heel straps cover your heel. If you were to capture a person's walking motion in slow motion, what you would actually notice is that sometimes the forefront of their foot is making contact with the floor, sometimes their heels are, and depending upon their gait, it's even possible that for a moment in time, there's actually no contact at all with the floor. And because of the way heel straps work, you've seen heel straps, right?
Yeah.
Okay? So a heel strap, because it's only covering the heel, other than where the heel strap is covering your shoe, the rest of your shoe is an electrical insulator. So when that electrical insulation portion of the shoe makes contact with the floor, it generates a static charge. If you happen to do that at the same moment as you stop so that the heel strikes the floor, that charge would immediately go to somewhere, hopefully, fairly close to zero. But because walking is you're moving, you're actually generating charges, and sure, they're discharging, but you're generating what we would call spikes of voltage.
When measuring walking body voltage, is that a measurement of the flooring itself or of the footwear worn by people in that room?
When we perform a walking body test to measure the static charge on people, one of the things we're actually learning is not just whether the floor does what it's supposed to do, but whether the ESD footwear that they're using does what it's supposed to do, and more importantly, whether the ESD footwear and the floor actually work with each other. So over the last 15 years, we've been working with a third-party testing lab that we send flooring to so that they can test it in a controlled environment. And by controlled environment, I mean an environment where they condition the flooring materials, and the footwear for that matter, at 12% relative humidity. And the reason for the 12% relative humidity is in all these ESD standards that you'll hopefully either already have or hopefully be obtaining based on our discussion today, the first thing you will learn about flooring for removing static electricity is you need to qualify the properties of the floor so that you can then make a decision on that flooring working under a low humidity condition. Because when you install the floor, it's very likely that on any given day, the relative humidity could be 20% or it could be 70%. And as a result of the fluctuating humidities in a lot of these factories, you could potentially qualify a floor in your factory, not in a controlled environment, on a day when the humidity is high, and assume that your flooring meets the qualification standards of the ESD Association, and not ever know that on days when the humidity is low, your flooring isn't doing what it's supposed to do. So the way the S2020 document handles that potential, I guess you could say, pitfall, is they want you to first qualify the floor. And by qualify, they mean send it to a lab, or if you happen to have the right humidity chamber to make these sorts of tests, which most people don't have, sure, you can do it yourselves. But you need to know what that flooring will do at low humidity using the footwear that you plan to use in your factory. So let me just back up a little bit, because this is kind of an important point. So suppose you're going to buy flooring and you decide that you're going to get brochures and literature from several different manufacturers. Every one of those brochures is probably going to have some statement or list of performance parameters that will include what we call walking body voltage and resistive properties. And if you look at the walking body voltage properties, I don't know a flooring manufacturer in existence that doesn't state that they meet ANSI ESD S2020. However, if you look more closely, what you'll discover is they don't tell you what type of footwear that flooring met the 100 volt maximum of ANSI 2020. They just tell you they meet it. What we've learned, kind of the hard way, because like any manufacturer, we're always trying to make sure that we stay ahead of things, is that certain footwear works better with certain floors.
All right, so we know that even if ESD footwear is being worn consistently, the particular type of ESD footwear will have an influence over the results of your compliance testing. Can you offer any real-world examples of this?
So, for example, one of the tests we did a few years ago was with an interlocking plastic floor that we thought looked like it was a very, very good product. And the literature actually stated that the floor generated less than 25 volts on a person per the ANSI test method for walking body voltage. However, when we did the tests at the third-party testing lab, we generated 700 volts on that floor. And the reason we were able to get 700 volts is we happened to choose to use ESD heel straps for the test. The reason we did that is the particular customer we were doing the test for asked us to make sure that we tested the floor with the type of footwear that they planned to use. And they didn't plan to use ESD shoes, which actually provide a full sole, contact area that has conductive properties. Like I said earlier in this discussion, heel straps only cover the heel of your shoe. So when you test the floor, you need to test it not only with the footwear that you will be using, but also the footwear you might give to a visitor. So this particular company wanted us to test it with heel straps, and when we did, that 25 volts with a particular ESD shoe became 700 volts. Not because the floor we tested was any different than the one the manufacturer tested, but because we tested it with footwear that essentially would not work with that floor. And that's a big problem because in my travels around the world, most companies, particularly electronics manufacturing of circuit boards and any kind of high volume electronics, they have a tendency to give their employees heel straps as their ESD footwear, not ESD shoes. So a set of heel straps probably costs somewhere in the vicinity of $7, $8. A pair of ESD shoes could cost $150. And because of the obvious need to control costs, you're going to notice that most factories use heel straps. So whenever we perform any type of testing on ESD flooring, we're always going to be including heel straps and several different types of ESD shoes in our test. So we can tell the client, this is what you can expect with this is what you can expect with that. Unfortunately, when you read the literature, it doesn't tell you that. And I'm talking about anyone's literature, ours included. Otherwise, the information would get too crowded. So normally when we work with a client, what we will do is we will also send them the test reports. That way they have the opportunity to look and see if they can confirm that the type of footwear they'll be using was in that test. The takeaways are, you have to measure the resistance from point to point on a floor. You have to measure the resistance from some point on the floor to ground. You have to measure the resistance that includes the person, the heel straps, and the floor. And you must measure the floor for walking body voltage generation using the type of footwear that you plan to use in your factory or any that you think you might be using in the future. And those tests should be done at 12% humidity. That's what we call the qualification phase of testing ESD flooring. We hope you learned something today. If you have questions about the podcast, give us a call at 617-923-2000. Even though we specialize in solving problems with flooring, if you have a question about static discharge, how to install a floor, how to test the floor, we'll be glad to help you. Thanks for listening.